Hi, guys. Welcome back to the classroom. Um, this morning we were talking about the thing that you see on the screen right now, right? This the dartboard. And we were talking about the fact that this dartboard not only helped us do our integer work because it gave us random numbers, but it also looked at the probability of how this thing would work. And what I meant by that was that figuring out probability is figuring out what the possible outcome is of certain random acts. If you have three darts and you're throwing it at this dartboard, how many different combinations of numbers can you get? Well, you can get a +5, +10, -2. You can get a +10, 2 -2s, all those other options that we were talking about in class. The one option we didn't do when we first did this during the math quiz is there's a possibility that someone could end up throwing a dart up here or throwing a dart up here and not getting a number at all. So what we tried to do was we tried to break it down piece by piece to see if we could figure out how many combinations there were. And it took a little while. Is there a better way to do this? Well, there is. It's called a tree graph, and it's a graphic organizer that you use to figure out all the possibilities of a probability question, okay? I've got a video to show you in just a couple of seconds that's going to go through all of that. What I want you to do is watch it and task it. Take notes, summarize, put together any questions you might have. And then once you've done that, do the work that I've thrown up on the Moodle for you to do tonight as homework. Now, there's not a lot of it there, but it might take you a little time because you're going to want to work through the entire tree graph, all right? So once again, watch the video, task it, do the work that's available, and we'll go through it again tomorrow. Good luck.
Suppose we want to list the possible outcomes for tossing this coin and rolling a die. What are the possible outcomes when I toss this coin? Let's see. I could get tails or heads. So let's write that down. I could get tails or I could get heads. Now, what about the outcomes when I roll this die? Well, we've rolled die before. I can get a 1, a 2, a 3, a 6. We know that we can get a 1, 2, 3, 4, 5, or 6. So I can write that down here. These are the possible outcomes for rolling a die. If I got a tails first. If I got a heads first, same thing. I could also get a 1, or a 2, a 3, a 4, a 5, or a 6. So all my possible outcomes would be tails and 1, tails and 2, tails and 3, tails 4, tails 5, tails 6, or if I'd gotten heads first, heads 1, heads 2, heads 3, getting pretty cramped in here, heads 4, heads 5, or heads 6. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different outcomes for this experiment. And you'll notice that what happened on the coin didn't affect what happened on the die. We also know that these outcomes are all equally likely. It means that if I toss a coin and roll a die, I'm just as likely to get tails and 1 as I am to get heads and 4, or any of these outcomes. We call this organizer a tree diagram because it sort of looks like a tree with the branches. But I wonder if the outcomes would be the same if I roll the die first. Let's see if our tree diagram changes. Well, we know I could still get a 1, 2, 3, 4, or 5, or 6. So let's do that now. I could get a 1, I could get a 2, I could get a 3, a 4, a 5, or a 6. Now when I flip my coin, well, we know I could get a heads or a tails. So if I'd gotten a 1 first, then I could get a heads or tails. If I'd gotten a 2, I could get a heads or tails. 3, heads or tails. 4, heads or tails. If I'd gotten a 5, I could still get heads or tails. And if I'd gotten a 6, I could still get heads or tails, because we know they don't affect each other. And let's look at our list of outcomes now. I could get a 1 and a heads, or a 1 and a tails. A 2 and a heads, or 2 and a tails. 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 and tails, or a 6 on the die, with the heads and a 6 on the die with the tails. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 possible outcomes, just like I had up there. And since the order of them doesn't matter, we can see that we have the same results. So now that we see that, what did we find out? Well, we can use a tree diagram to list all the possible outcomes of an experiment. And if we look a bit more closely at our tree diagram, we can see right here we've got heads and 1, and down here we've got the 1 and the heads. So those are the same outcomes, just listed in a different order. If we look at another example, here I have 2 and heads, or up there it was heads and 2. Again, here we've got tails and 3, and that was way down 3 right there.